The latest leave technique in regards to room specialists has presumed that, with our most recent 11 billion drive, it will take an outstandingly lengthy time span before this mission turns into a reality. If all that returns as projected, the journey to Proxima B is supposed to last roughly 20 years. Therefore, it will be a significant time before we can hypothesize about the presence of life on that planet. The profound space telescope has been vital in exploring whether we are genuinely alone in the universe, consistently providing supporting evidence through its revelations. The James Webb Telescope has uncovered interesting human-like objects far beyond Earth, carrying us closer to settling this significant inquiry. Our quest for life beyond Earth has been a continuous drive embedded in all human endeavors, to such an extent that we have built countless theories and media surrounding it. Our fascination with our place and significance in the universe remains ever present, deeply ingrained in our nature to diligently search for companionship, regardless of how similar we might be. This drive pushes us forward in search of answers. Yet, regardless of whether we get closer, can we be sure these answers are what we genuinely seek, or are they merely distractions? Join us as we explore the continuous and persistent discoveries being made in the vast realm of universes and planets on a journey that could uncover something we might not be ready to witness. The distant lights of other worlds. Researchers may have uncovered the most significant revelation in history. Back in 2021, when the James Webb Space Telescope was being developed, a strong and speculative question arose regarding the capabilities of our technology. The fundamental question was whether, in the future, our telescopes could detect artificial light on distant exoplanets like Proxima B, the nearest exoplanet to Earth. Proxima B, located approximately 4.25 light-years away, was believed to be tidally locked, meaning one side is continuously facing its star while the other remains in perpetual darkness, much like how our moon behaves. A potential technological advancement could enable the transfer of energy from the day side of Proxima B to its night side using solar panels that capture power from the starlight. A study led by researcher Manasvi Lingam and others demonstrated that a remarkable combination of solar cells on the day side could be connected with future telescopes. This is particularly relevant today, as the James Webb Space Telescope has been developed and could allow us to expand our search for artificial light on exoplanets like Proxima B. In fact, the James Webb Space Telescope's capability to undertake this very task in 2024, using its advanced resolution and capabilities, marks a significant achievement. The telescope may have already detected the very lights we were hoping to find, perhaps ushering humanity into a new era of scientific discovery. Let's delve deeper into the universe of exoplanets and galaxies to understand how this phenomenal achievement was made possible. The mission of the James Webb Space Telescope, JWST, to explore Proxima B is grounded in humanity's ancient fascination with the universe. Since the beginning of recorded history, humans have speculated about our place in the cosmos, questioning who we are, where we came from, and where we are headed. These timeless yet profoundly challenging questions have been central to human inquiry for centuries. With the advancements of modern technology, one wonders whether we are closer to answering these pressing questions. If you were to ask a philosopher, they might argue that we are merely at the very beginning of truly understanding our existence in the universe. On the other hand, an astronomer would likely enthusiastically present the latest discoveries about the cosmos using cutting-edge instruments. Often overlooked by the general public, these instruments are a direct reflection of human progress. We now have the universe spread out before us, and it is time for us to expand our understanding and embrace it with confidence. One way to achieve this is through the efforts of astronomers and space specialists who have been instrumental in developing new technologies to aid in the search for potential signs of life on distant planets. The James Webb Space Telescope, a marvel of human ingenuity, is central to this mission. This infrared telescope has begun addressing these age-old questions, pushing the boundaries of what is possible in space exploration. You may be wondering, what exactly is Proxima B? Also known as Alpha Centauri Proxima B, it is a super-Earth exoplanet that orbits an M-type star. To clarify, super-Earths are planets more massive than Earth but not as massive as ice giants like Neptune or Uranus. They vary in composition. Some are made of gas, rock, or a combination of both, and their sizes range from twice the size of Earth to several times its mass. Proxima B fits the definition of a super-Earth and is classified as an exoplanet because it orbits a star outside our solar system. The first potential evidence of an exoplanet was discovered in 1917, though it didn't receive much attention. It wasn't until 1992 that confirmation came with the first verified exoplanet discovery, which astonished scientists. Another exoplanet initially detected in 1988 was confirmed in 2003. As of April 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 systems containing multiple planets. Many of these exoplanets orbit M-type stars, the smallest stars in the main sequence, commonly referred to as red dwarfs. These stars are the most prevalent in the Milky Way, yet their low luminosity makes them difficult to detect, complicating our search for their light spectrum. Proxima Centauri, for example, shines at only 5 to 6% of the sun's intensity, emitting far less light energy than our sun. Over 85% of its energy output is infrared radiation, with wavelengths ranging from 0.045 to 0.056 microns. Proxima B's discovery was officially announced in 2016. But what sets it apart from the thousands of other stars, planets, and galaxies in our galaxy? There are several reasons why astronomers are particularly focused on Proxima B. Most notably, it is the closest known exoplanet to our Sun. While 4.2 light-years may seem distant, in the vastness of the universe, it is relatively close. Proxima B is part of the Alpha Centauri star system, a triple star system. Despite its low brightness, it remains one of the brightest objects in the night sky, following only Sirius and Canopus. Proxima B is even more intriguing because it resides within the habitable zone of its star, the region where conditions might support liquid water. This possibility has sparked intense interest among space scientists, prompting further research into whether the system could harbor life. This is where the James Webb Space Telescope comes into play. The 4 primary objectives of the JWST are to search for light from the first stars and galaxies formed after the Big Bang, study the evolution of the universe, investigate the formation of stars and planets, and examine planetary systems and the origins of life. As the JWST continues its study of exoplanets like Proxima B, we move closer to achieving these goals. The search for extraterrestrial life has now become a central focus of the mission, which is especially relevant given humanity's innate curiosity. Exploring the unknown is a natural extension of who we are as a species, constantly questioning, examining, and investigating everything, whether in motion or still. It is only fitting that such a grand mission would be undertaken on this scale, particularly in a universe filled with boundless possibilities. We are fortunate to be the ones searching for signals from distant civilizations. The quest for extraterrestrial intelligence can be likened to a high-stakes game of cosmic hide-and-seek, with humanity playing the role of the seeker and the universe as the hiding place. As we continue our search for signs of life beyond Earth, the potential discovery of artificial light or radio signals from distant exoplanets would redefine our understanding of the cosmos. It would raise profound questions about the nature of intelligence, communication, and survival in the universe. Could these signals be an attempt at contact, or merely a byproduct of a civilization's technological advancements? The challenge would then shift from detection to interpretation, understanding what these signals mean and whether they indicate an advanced, spacefaring species or a society in a phase similar to our own. Moreover, any potential discovery would require a carefully coordinated response from the global scientific community. International collaboration would be necessary to verify findings, prevent misinformation, and ensure that humanity approaches such a monumental revelation with responsibility and unity. Institutions such as NASA, the European Space Agency, and private space exploration companies would likely play key roles in framing the next steps. This underscores the importance of continued funding and investment in space research, as the knowledge we gain from exoplanet studies could one day become a defining moment in human history. The ethical dimensions of this search are equally critical. If we do discover intelligent life, how should we proceed? Should we attempt to communicate, or should we practice caution, mindful of the historical consequences of first contact scenarios on Earth? The possibility of encountering extraterrestrial civilizations forces us to reflect on our own behaviors and values. Would we be viewed as explorers or invaders? Would our interactions be peaceful, or could misunderstandings lead to unintended consequences? These are questions that humanity must grapple with before making any decisive moves. Ultimately, whether or not we find evidence of extraterrestrial intelligence, our search for life beyond Earth is an endeavor that fuels scientific and philosophical growth. It pushes the boundaries of what we know and encourages us to develop new technologies and theories. In doing so, we not only explore the universe but also gain a deeper understanding of ourselves. The James Webb Space Telescope and other future missions serve as stepping stones toward a future where we may no longer be alone, forever altering humanity's perception of its place in the grand cosmic landscape. As advancements in space exploration continue to accelerate, new missions beyond the James Webb Space Telescope are being conceptualized to push the boundaries even further. Future telescopes, such as the proposed Habitable Worlds Observatory and the Extremely Large Telescope, aim to refine our understanding of exoplanets by analyzing their atmospheres for biosignatures. These sophisticated instruments will provide more detailed insights into the chemical compositions of distant planets, allowing scientists to identify potential indicators of life, such as oxygen, methane, and other organic molecules. Additionally, the prospect of sending interstellar probes to nearby exoplanets, including Proxima B, is gaining traction. Concepts like breakthrough starshot propose using laser-driven light sails to propel tiny spacecraft at a fraction of the speed of light, potentially allowing humanity to reach Alpha Centauri within a human lifetime. While such technology is still in its early stages, the rapid progress in propulsion systems, artificial intelligence, and autonomous exploration suggests that direct exploration of distant worlds may not be as far-fetched as once believed. Beyond scientific exploration, the philosophical implications of discovering extraterrestrial life would be profound. The realization that humanity is not unique in the cosmos could reshape religious, cultural, and existential perspectives. Different civilizations throughout history have pondered humanity's role in the universe, and contact with an alien species could challenge long-held beliefs about our place in the grand design. It might also inspire a new era of unity on Earth, prompting us to set aside differences and recognize our shared existence as inhabitants of a vast and mysterious universe. In the coming decades, as technology advances and our ability to probe the cosmos deepens, the search for life beyond Earth will likely yield transformative discoveries. Whether we find microbial life on a distant moon, detect artificial signals from an exoplanet, or even establish communication with an intelligent civilization, each revelation will mark a new chapter in our collective journey. The questions we seek to answer today may ultimately define the future of humanity, guiding us toward a destiny that reaches far beyond the confines of our own planet.